Good day. I'm Dennis Todey, Director of the USDA Midwest Climate Hub. The Climate Hubs are a partner in developing this meeting that you're attending today and will be in person later this month as we talk about the issues of drought in a changing climate. Agriculture is a big component of this, a big impact of it, and a big part of the assessment that it goes on with dealing with the changing climate and drought issues. So we are happy to be part of developing and sharing this and this important idea of talking about drought in a changing climate. The map you see in front of you shows where the 10 hubs are nationally, if people are not familiar with those. We have other partners involved in the meeting today, Julian Reyes and Holly Prendeville, who have helped to develop and put this meeting on. Now let's start talking a little bit about terminology as we're getting into the discussions of the drought and changing climate. There's a lot we're going to be talking about in the next day and this afternoon, and we're meeting in person. And part of that is about monitoring, how we measure, how we use indicators, and how do we deal with the impacts of drought in a changing climate. That's not in question. That's something we've been doing for a long period of time. But as time goes on and as the climate changes, we need to understand how we assess the drought in a changing climate. How do precipitation, how does that context show in a changing climate? How do we put that into assessment and as we try to assess what the levels of drought are? And we'll talk about some of those as I try to cover some of these bits and pieces to get us kicked off here today. There's a lot we're going to need to talk about. I'm just trying to help set the stage for us right here. And that changing climate is part of the issue that we're seeing around the country. Not the same and looking in much different ways. The southwestern U.S., obviously, aridification, much drier conditions having widespread impacts because of the amount of agriculture, the number of people in a fairly dry climate, but also in the upper Midwest and Northeast where we're seeing more precipitation. One would think drought is not an issue, but drought is an issue in these areas and we have large impacts because of it. But because of some of the precipitation falling in larger events and having longer dry periods, which we'll talk about here a little as we go along, really changes how we deal with this and how we need to assess what's going on in the way of drought in a changing climate. So some other parts of this, some other things that we need to consider in this, how we assess period of record or how long we have data. Usually when we talk about comparisons to average, we talk about the last 30 years. We recently updated data for the last decade, so 1991 to 2020 is the last 30-year period we use for climate normals. But when we're doing drought monitoring and assessing, we want longer periods of record so we can capture bigger droughts as to try to put these in context. Like we want the Dust Bowl, we want the droughts of the 50s in the periods of record, so we can assess how bad or the situation was in those drought periods compared to what we've had in some of our relatively recent wetter periods. That's why the period of record then becomes a problem because we don't have longer periods of record like we do sometimes with temperature and precipitation. Some indicators and data sets have periods of record that are a decade or less, and then we're trying to compare what we get from those with some of those longer term periods of record that we have. So that introduces some error or some difficulties trying to assess these. Now, we're going to talk a little about the drought monitor. Drought monitor is not, because it's not the absolute assessment of what's going on in the way of drought in a changing climate, but it's kind of the de facto because that is what we're using from a policy perspective. Kicks off various USDA programs. That is what we're comparing to. That's what we're trying to put into with the U.S. Drought Monitor. Most people are probably familiar with this. I've included a picture of last week's U.S. Drought Monitor, and then on the right-hand side, some of the classification scales that go into that drought monitor that give us some of those categories that we look at for assessing where we are on those various levels. When you have a changing climate, those levels can be changing, and that's what introduces sometimes some discrepancies as to what we're trying to look at overall. We only go up to a D4 category. Theoretically, there are longer term changes and much drier that could indicate D5 or D6 based on lower percentiles, because what we use here are percentile scales, percentile rankings, There are lower percentiles beyond these that could be used, but we don't use on a regular basis because of the shorter term periods of record that we have. In addition, some other information that we use, and we're going to talk now about some of the pieces of information that go into the U.S. Drought Monitor. Sometimes people question, well, how much below or above average precipitation goes into the Drought Monitor? It's not that simple. We all know that. There is a lot of information that goes into that. Precipitation being the base one. We measure precipitation several different ways across the country on a more real time, on a daily basis, and then we put these into context based on certain time periods. Like here, I have a 30-day total precipitation for the upper Midwest, and then percent of normal comparison to normal. So again, we're using the 30-year category here. But that's kind of the context that we have and gives you some idea of what we're trying to deal with. We also, because precipitation is variable throughout the year, we have higher and lower precipitation times the year at various locations around the country, and certain periods are more variable or less variable throughout the year. So we try to standardize that monthly value into and monthly and longer term periods in what we call a standardized precipitation index. Basically, it's a value where you're comparing a precipitation value to a mean, whatever mean that period is, and then normalizing it by a standard deviation. So conceptually, it's a fairly simple idea that you normalize less variable months and more widely varying months to try to be able to compare them across each other. But again, when you're in a changing climate, when you have changing variabilities from location to location, sometimes the SPI doesn't give you quite what you're getting. But it still is kind of a base measure of how we deal with precipitation, show precipitation changes, how they are at different months of the year. Another indicator that goes into the U.S. Drought Monitor is soil moisture. Here we're showing a couple products, one a NASA product and one a Climate Prediction Center product. Again, a percentiles, because we use percentiles as our gauge for what goes into the U.S. Drought Monitor. So you even out some of those periods of record and some of the discrepancies. So what we have here for soil moisture is the percentile rankings, and you see some varying conditions. Percentiles work very well for soils because, depending on soil type, that gives you, a comparability across different soil types in different parts of the U.S. But again, when you're trying to get into, looking at a percentile scale that goes into the 100 category, and you're dealing with a decade or two, the percentile rankings don't always line up quite as much as we would expect them to. And then another component of the changing climate and another part of drought that we don't assess well because we can't quantify it nearly as well is evapotranspiration. And here I'm representing evapotranspiration. Again, evapotranspiration is water that is evaporated from surface or transpired through crops. When you're dealing with agriculture, that's a big player. And one that we really can't quantify very well. It's very difficult because it's involved by what the atmospheric demand is, how dry is the atmosphere trying to draw water away from that surface, and then the impact of the vegetation that's going through. How much water a crop uses varies by time of year, varies by its stress condition, a number of different things. So it's very hard to try to assess that. And then in addition to that, we have a changing climate where we have changing atmospheric moisture conditions, temperature conditions. It's changing how that ET is working, and when you can't assess it very well to begin with, that presents real problems. This product is called the EDIC product. It's dealing with atmospheric demand. It doesn't tell you absolute amounts ET, but it puts them again on that scale of where they would be on the D category scale, or here the opposite, the E category, how wet something is. To try to be able to compare with some of the other indicators. This is another area that we need to do more work as we're going along. So thank you for being here for part of this. I'm looking forward to continued discussions today and during the main part of the meeting. This is some contact information for us or with the other USDA climate hubs. Thanks for being here.